Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. It's the end of September, and partners from the project VESSEDIA converge in Austria to work out some last-minute technical details.
So we discussed both what we had done in the last half year, and we planned for the last 3 months what to do and to prepare for the final delivery, so to speak, of the project results. And we're in great shape. We all know what to do to make the project finish successfully.
That was Bart Jacobs. He's developing tools in VESSEDIA, and today they meet up at the Technicon headquarters in Villach for the last time as a group to applaud progress and address some open issues. I'm your host, Peter Ballant. Welcome to this episode of EUVATION. VESSEDIA, otherwise known as Verification Engineering of Safety and Security Critical Industrial Applications, is a European Commission-funded project which takes a serious look at building better software. Now, if you're thinking that has nothing to do with me, think again. Software is everywhere. Chances are, whether or not you're aware of it, you interact with software every day. Simply put, VESSEDIA is a software tool which helps software developers ensure their final product is free from bad code that could cause security problems down the road. Every day there are more and more internet-connected devices, and there's simply no room for any kind of breach. We have to do things now to ensure safety for tomorrow. This is exactly what VESSEDIA is doing. Let's go inside the studio and talk with Bart to learn more. Thank you for joining us in the Technicon studio today. It's very good to have you here as you are in Austria for your technical meeting of VESSEDIA.
Yeah, I'm very happy to be here. I'm very excited about this meeting and about our interview.
Now, I was reading a little bit about VESSEDIA, and this seems to me to be a very complex project. I'm hoping that you can kind of make this simple for us and tell us in a few sentences, if it's possible, what the VESSEDIA project is trying to do.
Right. So VESSEDIA is building a toolbox, so a set of software tools that will enable, or that are supposed to enable, or intended to enable, developers to ensure the safety and security of the software that they produce.
Okay, so for me this makes sense, but what about someone who's not necessarily interested in software security? Just the average person who goes out and buys a smart home system. What benefit do they have? What benefit would they have as a result of VESSEDIA?
The benefit is that their smart home system will not get hacked remotely, right, through the internet by criminals trying to either just perform vandalism or actually extract private information that they can use to steal your money, etc.
So if my thinking is correct, these devices, they're all around us. They're smart devices all around us, and they affect everybody. So we could say by building better software, VESSEDIA is helping everybody.
That's right, sure. I mean, more and more consumer devices, as well as business devices, have software in them, of course, and are also wired up to the internet of things, right? I mean, it's a trend that's very strong, and which means linking up all kinds of everyday devices like fridges, etc., up to the internet, which has lots of benefits, but also, of course, risks. And we have seen a number of exploits or attacks that exploited these devices to all kinds of damage.
Very interesting. Do you have an example of a situation like this?
So there was a case of a smart aquarium being used to exfiltrate information from an office that had this aquarium in it, and some private stuff was being discussed in this office, and it was captured through this smart aquarium. This
is amazing. So when we hear a story like this, is it possible that with more robust software, this situation could have been prevented?
Definitely. So in this case, like in most of these cases, it is through programming errors in the software. So people who created that software made some errors, some logical errors that they weren't thinking very carefully at that point. And therefore, this allowed attackers to exploit that error and insert their own code and their own commands into that device, so that it would do what the attackers want rather than what the original developers want.
Can you, Bart, explain to us your role in this project personally?
So I'm one of the tool developers. So as I said, the project is developing tools and also validating them, using them in some use cases. I'm one of the partners that is developing one of those tools. So I'm developing the Very Fast tool, which tries to look for programming errors in pieces of software.
And when you say this software, are we talking about open source? Is what you're doing open source, or is this proprietary in some way?
So the tool that I'm building, Very Fast, is open source. So you can find it on GitHub. And I've been building it actually since 2008 with my group. And so in the VESSEDIA project, I'm improving this tool to make it even better and more performant.
And I want to get back to these specific examples. In a corporate setting, what kind of attacks could take place?
Mm-hmm. So this is not hypothetical. It's happening all the time. Attackers are using these programming errors to take over machines in businesses, so the computers in offices of corporations, to install what is known as ransomware, where the attackers encrypt, so make unavailable all of the data on the machines of the corporation, and then they ask the people to pay money, so pay a ransom to get back their data. And this is happening all the time, and it's costing a huge amount of money to the corporations, and it's also making these criminals very rich doing that.
So this can't be legal. Why can't these people just be arrested and put away?
Yeah, so it's very hard to track them down. It's very hard to identify these people. Also, they are often in jurisdictions very remote from the places where the attacks happen, of course. So that's the problem.
So it seems to me that being proactive in this kind of situation is more important than even, for example, being proactive by locking the doors on your house, because if somebody breaks in, they will catch these guys. With this cybersecurity realm, there's very little chance of catching the perpetrators.
That's right. It's much easier to perform anonymous attacks, untraceable attacks in the cyber realm than in the physical realm. That's true. So indeed, there's really no alternative to making sure that your software has good quality and is secure upfront.
And so this is what makes VESSEDIA so important then.
That's right. Yeah. So we're contributing to the state of the art in the techniques for doing that.
The VESSEDIA project is almost complete. Is this right?
Yes. So it's only 3 months to go now.
Okay. Can you evaluate how the progress has been to date? Are you satisfied? Are your project partners satisfied?
Yes, we've done a lot of good work. So we've made a lot of improvements and steps forward. We have done many different things. I can enumerate some. So myself, in my group, we have developed new techniques for ensuring that particular kinds of programming errors in so-called concurrent software where multiple things are happening at the same time, don't go wrong. So that you don't have deadlocks. So where pieces of software wait for each other all the time and no useful progress is done anymore. And this could lead to denial of service attacks. So by applying the techniques that I developed, denial of service attacks become harder to perform on this software.
Did you encounter anything unexpected during the course of the VESSEDIA project?
Well, of course, we shoot for the stars at the start of the project, and we always have to adjust our goals to the more realistic goals as we go along. But that's in a way expected. I don't think we really had any major issues during the project.
That's good. Yeah. With many of the projects that we're involved with, we see some sort of demonstrator at the end or something tangible. At the end of VESSEDIA, will there be anything? Will this toolbox be ready? Will it be able to be distributed?
Yes, so the answer is yes. We will be demonstrating during the review meeting some of the tools that we've been working on. So some of the tools, they already existed and we've improved them. Some of them are new. And so yes, we will have a lot to show at the end.
And this being the case then, what happens to VESSEDIA after the project is over? Is there a chance for a similar follow-up project to take place?
Definitely. So I fully expect that we will be able to continue this work after VESSEDIA. So there's, of course, we have achieved much, but there's much yet to be done afterwards as well.
So if you look 5 years into the future, can you see a way that VESSEDIA perhaps has helped the software development community? Can you pinpoint what areas you have helped with?
So one major achievement of VESSEDIA is that we now have much better support for verifying C++ programs. So that's one of the programming languages used very often in all kinds of devices. And we have made it much easier to apply verification to C++ programs. So I think, yes, indeed, thanks to VESSEDIA, many more devices will be able to be verified and checked for these programming errors in 5 years' time.
And speaking of verified in Europe, this is a brand or a mark that is a result of the VESSEDIA project. Can you tell us a little bit about this?
Yes, so that's something we're developing to make it easier for the end user, both as a consumer or as a business, to assess and be aware of the security problems or challenges in devices, and also the fact that certain vendors have indeed applied best practices to prevent security problems. So in this project we propose a label, as you said, that vendors can put on their devices to indicate that they have applied the VESSEDIA toolbox to ensure the safety and security of their products.
And this also is something that is tangible that has come out of the project.
Definitely, yeah.
Okay, and I'm curious, what is it like working in a project where your partners are scattered all over Europe? Because the beauty of this project is the diversity of the team, but you're in different locations. How does this work for you?
Yeah, so we have lots of meetings, all in different locations. So that's fun by itself to visit all of these places and all of these institutions that are our partners. It worked fine. We have well-defined work packages assigned to each of us. So we can work to some extent independently. But as I said, we do meet a lot, and then we coordinate our activities. So it worked fine.
Yeah, very interesting stuff, and I want to say thank you for taking the time to speak with us today. You were very busy with this technical meeting, so I appreciate you coming down to our studio to talk with us. And you only have a few months, so we wish you success in the upcoming time of the project and in future projects as well.
Thank you very much.
This podcast has been brought to you by Technicon. The VESSEDIA project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 731453.